In this video, we'll explore how lone pairs of electrons allow molecules like ammonia and water to form coordinate bonds with protons, producing ammonium and hydronium ions, and how this behavior underlies self-ionization and acidity in aqueous solutions. Atoms such as nitrogen in ammonia and oxygen in water possess lone pairs, pairs of valence electrons not involved in bonding. These electrons sit on the atom as a concentrated negative region. Lone pairs can act as electron donors, making these atoms Lewis bases capable of forming new bonds with positively charged species. A coordinate, or dative, bond forms when one atom donates both electrons in a shared pair. For this to happen, one partner must have an available lone pair, acting as the donor, while the other partner must be electron deficient, such as a proton, acting as the acceptor. Together, they create a conventional looking covalent bond with a special origin. Ammonia, NH3, carries a lone pair on nitrogen. When a proton, H, approaches, nitrogen can donate that lone pair to bond with the proton. The result is the ammonium ion, NH4, where nitrogen now shares 4 N-H bonds. The new N-H bond originates from the lone pair, but once formed, it behaves like any other covalent bond. When writing this interaction, ammonia is combined with a proton to yield ammonium. The coordinate bond is often indicated by an arrow from nitrogen toward the new hydrogen, emphasizing electron donation. This representation highlights Lewis acid-base behavior. Ammonia is the Lewis base donating a pair, and the proton is the Lewis acid accepting it. Water molecules also have lone pairs on oxygen. When a proton encounters water, oxygen can donate one lone pair to bond with H, forming the hydronium ion, H3O. Hydronium is the actual carrier of acidity in aqueous solutions. What is often called a free proton in water is, in reality, this H3O species. Even pure water undergoes a tiny amount of self-ionization. One water molecule donates a lone pair to a proton generated from another water molecule. This produces a hydronium ion, H3O, and a hydroxide ion, O. The balance between these ions defines the pH of water and underpins acid-base chemistry in aqueous environments. Lone pairs on nitrogen and oxygen enable molecules like ammonia and water to donate electron pairs, forming coordinate bonds with protons. This process creates ammonium and hydronium ions, and in water, leads to self-ionization. Understanding these electron pair donations explains how acids, bases, and pH behavior emerge in aqueous chemistry.